okay? But unfortunately, in advanced stages of cancer, this is what's happening. The body's trying to produce so many of these cells to go fight the invaders, it can't win the battle. So all the energy is going to that. So as we begin to create our T cells, because we need them to duplicate, they need to duplicate with the materials that are going to be able to go to that infected cell that are going to be able to kill it. And they're going to act directly on the cell itself. Hopefully by either that apoptosis, cytolysis, whatever the case might be, the foreign invader is going to die and we take care of the infection. When it is humoral immunity, this is a little bit more indirect. We're going to produce antibodies. Their goal, attached to the antigen. In the video, she had the antigen up in the corner of the PowerPoint slide. And then it kind of bright lighted the little pieces on that antigen, and it was showing the antibody like right there underneath that particular cell, okay? So basically what was going to happen is that antibody was going to attach to those little epitopes. Do y'all remember the little stuff that lit up? Okay? And what that did is it would tag that cell for destruction. So the one that she drew in the corner of the PowerPoint, and she had these little things drawn to it, and then they lit up, okay? When this antibody binds to it, this foreign cell, the antigen, okay, is now tagged. And if it is tagged, it's going to get destroyed. So, B cells that have that, okay, that ability to do that, we're going to see some plasma cells get developed. Did y'all notice that in the little PowerPoint presentation? Those are cells that are coming from B cells because they are going to get formed at that moment in time. They are not cells that are going to be stored in the lymph nodes. Plasma cells are going to get called up and formed at that point in time, meaning B, bone marrow, i.e. humors, because that's the blood. Does that make sense? Okay, so we're going to see that we'll have them act as antigen presenting. They'll have the MHC2, which, like I said, I'm not going to get heavy into that. We're going to have the antibodies and the complement factor. Do you remember what happened with complement? What that is? Complement was the groups of proteins that got formed, and in the video that we watched on Tuesday, they looked like the little teeth that went and attacked. They kind of formed a circle and attacked the plasma membrane of the cell. Do you guys remember that? Complement, how if we started one complement factor, it created a cascade reaction, and once those complements were formed, they looked like the teeth going into the cell. And then, do you remember what happened to the cell? If those complements, it burst. It allowed contents of the cell to leak out. So complement will get activated. So the mechanisms for killing the cells by way of humoral immunity. We can burst the cell. We can help macrophages eat the cell, the foreign particle. It can work on immune clearance by way of those immunoglobulins, okay? We can start inflammation. Neutralization would be chemicals that would create environments that are not going to be conducive to it. Agglutination, because with an antibody having the structure that it has, it can attach an antigen, and then if I've created other antibodies, they can attach it and attach it. And if we agglutinate, they come together. Think about getting the blood transfusion with the wrong type. That is actually this reaction occurring. When you're given the wrong type of blood and those red blood cells agglutinate, this is what's happening. Do you remember that? The antibodies that got formed? Okay, that's what's happening. Precipitation, when that agglutination, that product falls out. And then, yes, we create memory cells out of the B cells. Now, when this occurs, when those B cells create memory, they will be, you remember the structure of the lymph node and how we talked about the little dips in the outer cortex, and those being the germinal centers, okay? That's where my B cells are going to be residing. So the next time the invasion comes along, we get a very quick response from the B cells. T cells, their memory, when they create memory cells, those can last for decades. Okay? B cells, some of them only last a short amount of time, a couple of years. Okay? Some of them can be longer, all right? But the really long memory that gets created is usually our T cells. And when you have, and I forgot to look it up, what was it called again? PERP? For the HIV?
Oh, yeah.
PrEP.
P-R-E-P.
P-R-E-P. Forgot to look that up the other day. When that memory, because see, think about it. This is what took decades to determine about that virus. Because, first of all, it took decades to find out that it was a retrovirus, which was huge in the medical community, okay? Y'all got to remember, I was old enough to know when all of this was happening. I mean, the beginning of it, the study of it, everything. I've been through all of it with the HIV. And so one of the things about it, you know, that was attacking those T cells. And that was what they had to figure out. They had to figure out why and how and all this sort of stuff. Because it was the T cells that provided long-term immunity. And the reason people were dying, okay, well, you know, HIV was just being infected with the virus. AIDS was the full-blown disease, and people died from stuff like a cold or the flu or something like that because these opportunistic infections, the body wasn't able to fight them off because the T cells had been destroyed. So that was actually, you know, and different cancers because the body wasn't able to fight it off. So these were things that were happening. So in the B cells, they're going to have on their cell membrane the antibodies. These antibodies will have a way to recognize a foreign particle. When they recognize the foreign particle, T helper cells can be used. The epitope is what's on the antigen. The B cells are going to have the ability to attach to that antigen. One of the things that will happen with the B cells are going to create more, just like T cells can do, and they're going to be called our plasma cells. The plasma cells, as they get created, they're created with information to make this particular antibody. In other words, make this cell have all those antibodies on it to connect to that antigen, and then tag it for destruction. And when it does, those antibodies can get released. Antibodies can go, we can get more plasma cells, we can get more antibodies, more plasma cells, more antibodies, go, attach to those antigens, tag them for destruction by these lymphocytes, these other immune cells, these macrophages, whatever the case might be, to kill it. And then, of course, let's create some memory. And let's go sit on the lymph node and wait. So if we ever get exposed to it again, hopefully it's taken care of. But not everything done this way creates long-term memory. B cells, T cells. Gotta love them, right?
So what is it about the HIV virus that they haven't been able to create a
Viruses, unfortunately, one of the things about viruses, they have the ability to mutate, and the proteins that show up on their surface are not always, I just can't work this way. I gotta do it this way. They don't have the ability to evolve quick enough. So that's why I'm gonna look up the PrEP. Did y'all say that that was a vaccination?
It's not a vaccination. It's a pill. It's a pill that you take to help. It's like a I think it kind of acts like a how girls take the what's the pill called?
The birth control?
Yeah. Well, you know, like the day after. So like if you are exposed to it, you have a 75% chance of not getting it if you're taking this pill.
And I'm guessing PrEP stands for something.
Yes.
Okay. I'll look that up on break. Okay. So if I'm not mistaken, because didn't they just have like a second person that they cured?
Yeah.
From it also?
From HIV.
Yeah.
Yeah. If I'm not mistaken, there's been a second person, right, Michelle?
Yeah, it's because some people are born with it,
with a particular gene that makes them immune to HIV.
Who was that the case?
Yeah, because I can remember going to a lecture.
Or something, and some cells.
Yeah.
He's the second.
Truvada.
Yeah. What is it?
Truvada.
Yeah.
What now? What's Truvada?
It's the PrEP. It says for PrEP, pre-exposure prophylaxis.
Okay, read some more to me.
Oh, I'm going more. Okay. Oh Lord.
Pre-exposure
It
prophylaxis.
says you must be HIV negative before you start and while taking Truvada for PrEP. Do not take Truvada to reduce the risk of getting HIV-1 unless you are confirmed to be HIV negative. It says to further help you reduce your risk of getting HIV-1.
HIV-1?
Mhm.
Okay.
Because I think
Telling me.
you can get HIV and be undetected.
Right. And then it has to develop some more in the body to get it detected.
It says it's a way for people who do not have HIV but who are at substantial risk of getting it to prevent HIV infection by taking a pill every day. The pill, brand name Truvada, contains two medicines, I'm not going to pronounce that are used in combination with other medicines to treat HIV. When someone is exposed to HIV through sex or injection drug use, these medicines can work to keep the virus from establishing a permanent